The last thing we'll look at in this section is the idea of some of the identities that come into play with trigonometric functions and how the trigonometric functions relate to each other. We've already looked at one set of those identities. In particular, we've noted that the cosecant of theta is simply the reciprocal of sine. We've noticed that the secant of theta is the reciprocal of cosine, and that the cotangent of theta is the reciprocal of the tangent of theta. We've also noted previously that the tangent of theta is sine over cosine, which leads us to the cotangent of theta is the cosine over sine. All of these are relationships that you'll use on a regular basis. One of the other identities that we're going to look at now is the cofunction identities. First of all, you need to know what a complement is. The complement of an angle, you may remember from geometry, is the idea of two angles that add to 90 degrees. Or in our case, if we're dealing with radians, pi over 2. The relationships that I want to make sure you know is that the cosine of an angle is equal to the sine of the complement, because notice the complement here, pi over 2 minus theta, that means that 90 degrees minus the theta is the complement. Likewise, the cosecant is equal to the secant, and the cotangent is equal to the tangent of the complement. Where this comes in handy is if we want to do some calculations. So let's express some of these with their appropriate cofunction and evaluate the equivalence of the two expressions. Consider the cosine of negative 5 pi over 11. We know from the last identities that we just went over that the cosine is equal to the sine of the complement. So we're going to take pi over 2 and subtract the original theta. When we do that, we end up with the sine of 11 pi over 22, finding our common denominator, plus 10 pi over 22, which leads us to the sine of 21 pi over 22. If we use a calculator, you can verify that both of these come out to approximately 0.1423. So the identity is true. Another way that we might use these relationships between trigonometric functions is if we're trying to determine a certain value given one value. For example, if I know that the cosine of theta is negative square root of 3 over 2, and that the tangent is negative, let's determine theta. And let's determine tangent. In our last section, we talked about the idea of knowing the quadrants and what was positive where. And if you remember, all students take calculus. We know then that if the cosine is negative, here all the trig functions are positive. Here only sine, here only tangent, and here only cosine. Since in this case both are negative, we know it has to end in the third quadrant. So we can draw some sort of angle here, and we can take some reference angle. From that reference angle, we know that the value is cosine is square root of 3 over 2. That gives us some y value. We know the x value is negative square root of 3. And to determine the y value, we can use either the Pythagorean theorem or the triangles that we're already familiar with. Hopefully you're starting to remember these relationships, that if you have 2 and square root of 3, the other side is going to be 1. So to calculate our tangent value, remember tangent is going to be opposite over adjacent, which is going to be 1 over the square root of 3. It is negative because it is in that second quadrant. And then that theta value, again, from our relationships, we know that theta is going to be 5 pi over 6, since the reference angle itself is going to be pi over 6.